Hi, I'm Bob Helsel from the IVI Foundation. Welcome to the IVI Getting Started Guide videos. Our purpose is to provide you with an easy tutorial on using IVI drivers in the development environment of your choice. After a brief introduction, a technical expert will show you how to use drivers with your ADE. First, I'd like to go over a few key benefits in using IVI drivers. They will save you time in your program development. Number one is interchangeability. IVI drivers enable the exchange of instruments in your system with minimal code changes, reducing time and effort. Two, ease of use. You can use your favorite ADE such as Visual Basic, Visual C++, LabVIEW, LabWindows, MATLAB, or V. The standard APIs provide fast, intuitive access to functions. Three is quality. You'll have common commands and desirable options. The Foundation's rigorous testing ensures driver quality. Four is simulation. Simulation allows code development and testing even when an instrument is unavailable. We'll be taking advantage of the IVI simulation feature as not all viewers will have this hardware available. Fifth is performance and reliability. Examples of these are capabilities such as range checking and state caching. These are some of the key features of IVI drivers that will cut your program development time. In order to follow along with this tutorial, you'll first need to download and install an IVI driver. There are two ways to do that. You can go to the driver registry page on the IVI website, or you can go to the instrument vendor's website. Find the 34401A driver, download and install it before taking the tutorial. Now let's go to the product expert for your ADE.
Hello, and welcome to the IVI Getting Started with LabWindows CVI tutorial. My name is Lars Lindstrom from National Instruments. LabWindows CVI is a proven ANSI integrated development environment that makes it easy to control and acquire data from any instrument over any bus. This software platform combines the longevity and reusability of ANSI with the engineering-specific functionality designed for instrument control and user interface development. This tutorial will illustrate just how easy it is to use IVI drivers in the LabWindows CVI environment. Now, in order to follow along with this demonstration, the minimum software required is listed here. For assistance finding and installing the software, please refer to the IVI Getting Started PDFs on the Resources page of the IVI Foundation website. Now to begin, we first need to launch CVI by going to Start, All Programs, National Instruments CVI. On the Welcome page, we're first going to press New Project. We're first going to create a source file by going to File, New, Source. I'm going to go ahead and save this to my hard drive by going to File, Save Untitled As. And I'm going to give it the name IVI Getting Started. Then, in order to add this file to my project, I'm going to go ahead and right-click on it and go to Add Existing File. I'm going to select the file that I just created and select Add. In order to get access to my IVI functions, I'm also going to need the .fp file that was installed along with this driver to my project. All installed IVI drivers can be found by going to C, Program Files, IVI Foundation, IVI, and Drivers. As you'll see, we have the 34401A driver listed here. If I look inside, I should have all the files associated with that driver, including the .fp file. I'm going to go ahead and add that as well. As you can see, by loading this FP file, CVI has automatically given us access to all of the different functions that are included with this particular driver. Next, in order to give my source code some structure, I'm going to go to Edit, Insert Construct, Main. I'm then going to add another #include for this particular driver, which is called HP 34401A.H. In order to verify the actual name of the driver that you're using, you can check this by going to C, Program Files, IVI Foundation, IVI, and then Include. As you'll see, we do have the HP 34401A.H file. This is automatically searched when you run anything within CVI. In order to begin communicating with the instrument, I need to drop down an Initialize with Options function, which I can find here in the palette. I'm going to drag this into my source code window, where I can then see the required inputs for this function. Then, after recalling the function panel, you'll notice that we can specify a few things, including the resource name of the instrument, whether we want to query the ID of the instrument, whether we want to reset the device, and finally, a string input where we can set various options that will be particular to this session. As mentioned in the introductory video, there are many advantages of IVI, including range checking, state caching, and instrument simulation. Since I don't happen to have this benchtop instrument right next to me, I'm going to go ahead and take advantage of that last IVI feature by setting the simulate parameter from 0 to 1. This means that the feature will then be turned on. The last important input for this initialize is the instrument handle parameter. Here I'm going to go ahead and declare a variable named session, where I will store my reference to my hardware session throughout my program. I'm going to go ahead and declare this variable by hitting Control-D. I'm going to make sure that this declares it at the top of my target file. Finally, I'm going to go ahead and insert the completed function into my code by selecting the Insert Function Call toolbar button. I'm going to hit Replace because I want to replace this code that we've then developed here on the bottom with my empty parameters there on my code. With the device initialized and a valid session returned, we can go ahead and start configuring our instrument. To do that, we're going to open the Configuration section, and we're going to drop down the Configure Measurement function, as well as the Configure Trigger function. Now that everything is configured, we can now read from our device. To do this, we'll go to the Measurement section, and we'll drop down a Read function. The last step is to close the session, as we want to be sure to close out all of the open references to our instrument before the program completes. To do this, we're going to drop down a Close function. Now, rather than spending all the time filling in all of these parameters for the functions, I'm going to go ahead and open up my completed example. You'll notice that in addition to my IVI functions, I have added both a printf and a getChar function, which are used to show the simulated values to the user. The printf statement will launch a command line window with the value of the reading variable displayed, and the getChar function will force it to wait for the user to press any key before continuing. I've also added our session variable as an input to each of the functions. I'm going to go ahead and run this example so you can see how it works. As you can see, my simulated DMM brought back a value of 5.138707. Now I built this example from scratch, but most of our IVI drivers do ship with examples to get you started. These can be found in C, Program Files, IVI Foundation, IVI, Drivers, and then your driver name. As you can see, we do have an example.c file in this directory. This concludes the IVI Getting Started guide for LabWindows CVI. Hope you've been able to see how easy it is to bring IVI drivers into the LabWindows CVI environment. For more information about LabWindows CVI, please go to www.ni.com/lwcvi. For additional information, including videos, tutorials, and more documentation, you can go to the IVI Foundation website at www.ivfoundation.org. Thank you.